All right, I think we are ready to start. Okay, hello and welcome everybody to the 5th Rust Meetup, brought to you by the Coding Club Linz. My name is Patrick, and I would like to... pardon, I need to mute me on... sorry. My name is Patrick, and I would like to invite you to our Discord channel to discuss with others during the session or to ask questions, which I'm glad to forward to the speaker when there's time to. Today, we have 3 speakers. First of all, it's Stefan Baumgartner with his talk about The Exorcist. I'm really looking forward to hear what stands behind this title. Next, Rainer Strobeck talks about web APIs with Rust Rocket. And last but not least, Stefan Schindler talks about atomic counters and cache lines. All right, let's dive into the first session. And Stefan, the stage is yours. Yeah. Let's give me a second. Need to unmute. Where is this? Some seconds. I am almost done. I need to find him. Yes. Yeah.
Here we are. Hi. Can you hear me, Patrick?
Yeah. Looks good.
All right, cool. Hey, friends, how are you? How is everybody? So thanks for this opportunity to chat a little bit about how I learned Rust. So, we here at Rust Linz, we are a beginner-friendly meetup. There are a couple of people here who barely have scratched the surface of Rust and who have barely had the chance or opportunity to dive deep into Rust as a programming language, let alone create some production code with it, some systems that run and are used by real users, not just demos. And as it turns out, I myself had the same problem. Most of the time I'm writing JavaScript and TypeScript. For about, 15 years now, I've barely touched a different programming language, but Rust was one of those programming languages who caught my interest. It looked interesting. It was the people around the community had a great way of describing it, especially, Ryan Levick, who was here at the very first Rust Linz meetup. Was a guest in my podcast once and did some great introduction to Rust. And ever since, I wanted to try it out. But I had the problem, I didn't know how to start, especially when you're doing one particular programming language for so long, and especially once you have a certain age and some responsibilities, like, kids. Taking the time off to learn something new gets really, really hard. But I found a way. To learn a programming language, to learn basically almost any programming language, like have to pick a little bit, 52 programming languages through a tool called the Exorcist. And I'm going to share my screen now because I guess that's still missing. You should see my entire screen right now. Alrighty. So this is the Exorcism homepage. It's called Exorcism. That's why my talk is called The Exorcist. And it's code practice and mentorship for everyone. This is their tagline. What you're doing is providing an interactive system. You sign up to so-called tracks, where you can learn the programming language exercise by exercise by exercise. They feature a ton of programming languages, 52 of them. There they are. Here's the overall logo wall, and you see some familiar logos here. And one thing that I was interested in was Rust down there. This is the Exorcism homepage. I can't access anymore because I'm logged in always. And this is how it looks once you are logged in. So this is me about 15 years ago. And this is the one track that I have joined, the Rust track. I already completed 32 exercises. And for me, it was a really good way to get familiar with the programming language. So if I go in, you can see that there are 93 exercises, and those are the exercises that I have already completed everywhere where there's a check mark. And I did start at the very first exercise, going through to one that alphametics, where I still have to find my way around. But there are tons of exercises there, even one that you might have developed already in Rust, a simple linked list, because that seems like to be one thing where even the compiler gives you a proper solution for what you want to solve with all the boxes and options that you get, down to the one exercise or a couple of exercises that are really, really hard, like maybe the doubly linked list. I'm not sure if I want to reach that level. Anyhow, if we look at one particular exorcism exercise, what you get is an introduction of what the exercise is all about. So there's some introduction there. It explains to you how you should approach this exercise. It's not only that, but there's some tests to it. I'm getting to that in a bit, and also some commands on how to run them with the programming language that you have been using. So the exercises are somehow similar across all the programming languages that there are, but they have been adapted and refactored to suit the needs of the programming language that you are currently using. Not only that doubly linked lists are marked hard, but also some hints regarding crates that you can fetch on cargo. Also some information on how to approach, let's say, Unicode characters with graphemes, and which crates to use for that. So there's lots of support and lots of information, particularly tied to Rust. Also, there was one example where I had to work with lifetimes or custom created lifetimes for the very first time. There was an explanation on what to do and where to find information and some guidance on that. This is the introduction. One thing that I liked particularly about that is that I had to download the whole thing. So there's a command line tool called Exorcism. I installed it with Brew back in the day. I had to download the example. There's no online editor, even though it's possible. And I think they're working on a relaunch of Exorcism where you can use an online editor. But I found it particularly nice to work with the real tools on my hard disk, because I was able to learn the tool chain. So of course, demos and exercises and learnings are always great if you don't have to worry about tooling. But in my particular case, I thought I want to get around how to use cargo, what the commands are there, how to compile them, to work with Rust up, etc. So this is also why I think that the very first exercise, the Hello World, doesn't get enough recognition. It's not about getting familiar with the main syntax there. It's about getting to know the tool chain, getting to know how you compile stuff, getting to know how to create the binary that you can actually run. So once you are downloading exercises from Exorcism, you get the whole introduction in a README file again, and you have two folders. One is the source file with the librs. So this is, I guess, this is the ETL example where we try to get a list that looks like that and create the list that looks entirely different. We have to look it up in the tests in a couple of seconds. So there's one librs file, and this librs file is usually empty. So this is already the implementation that I did. And there's also a couple of tests. And the very first test is active. The other ones are usually to be ignored. And you can learn a lot from the tests. So this is something that I really, really enjoyed working with Exorcism, because you have test-driven development. You have tests that are optimized for the programming language that you work with. This is also what I think very, very important. And then you can learn from the tests how you want to develop your exercise. What I usually do is like going really test by test by test by test. Sometimes my algorithm that I developed was good enough to just pass all tests, and then it just needed some information, some adjustments in the end. At other times, I had to activate all the tests to get around what I wanted to do or what I wanted to achieve. There was one exercise that I found particularly challenging, which was scorecards for bowling, because never ever in my life have I been playing bowling, not even back in the day when it was still allowed to hang out together. So still, I managed to come around that. I even read up some Wikipedia articles there, but usually the tests are good enough and all that you need to find your way around what is a question from you, like what is the challenge, what do you want to solve. Also, if it's, for me, it's also great to have tests to know if what I'm doing was actually right, to know if my exercise has been successful. There are also sometimes bonus activities where I can say, okay, up until then, it's just like the challenge level describes it to be, but from there on, there are some bonus challenges that you can take where it gets a little bit harder, and they're also very, very exciting. The fun stuff is once you start submitting your exercise, you can submit almost like having some version control. And once you are done, and once you think you're really ready, you click the submit button in the user interface. And what happens then? Let's go to one that I already solved. This is the grade school example where I also had to reformat some data. So I got data in one way and had to format it in another way. Here was the test suite that I was working with, and this was my solution. So I even had to implement a struct there. This was one where I even got a star from the community, because what happens then is you have 3 possibilities. First, I could request mentor feedback. So there are real actual people behind Exorcism who take a look at your solution and give you feedback on that. You can ask them questions and they will answer. Disclaimer, not in time. So I waited about 3 weeks for my answer, because they are swarmed with students who want to have feedback. And what I know, it's just labor of love. It's not something they get actually paid for. They do it in their spare time and try to mentor you as good as possible. I requested once feedback where I tried to create a prime number algorithm where I thought, okay, there must be a much more idiomatic way to do so. It took a couple of days until I got feedback, but the feedback was very valuable, with a couple of links, a couple of solutions that I could link into to get inspired or get more feedback to. And that is one thing that I actually like most, which is view community solutions. So I can take a look at solutions. Here's my star, look at that, about solutions everybody else did. So usually you find out that there are a couple of people that are doing the exercises with you, like they have a similar progress. I guess this person, I peeked into their results a couple of times. You can open them if they want to share it. You can read their solution, get inspired, and if they have some comments there, it's always very, very helpful. So what I started doing was commenting my examples as well. Try to give some feedback, try to give a comment on what I thought about creating my solution, submitting it, and hopefully people found it interesting. So there is the possibility, it's not very active, but there's the possibility of a discussion that's going on and that is happening. So help others help you, and help you help others. I guess that's the mantra of this particular thing. And with that, I think I did about a third of all the exercises, and I think I got really, really far to try my own example afterwards and to try to work on some actual production code. This is why I guess I didn't try another exercise for the last 30 days or so. But I'm eager to dig deeper into what's offered there. And for that, I think Exorcism helped me a lot. I can recommend it to everybody who has no idea how to start. You can read books, you can watch tutorials, you can read blog articles, which I do a lot. So I read a lot. I try to be informed on what's happening. I go to online conferences. Stefan is here in the Zoom chat. He did a great job with his colleagues for Rustfest just recently. I enjoyed watching those talks a lot. I still had no clue how to start. And this helped me, giving me very mundane, very generic examples. Computer science 101, the stuff that you learn when you are in high school, when you are at university, very basic examples that bring you closer to the programming language again, without forcing you to work with a certain domain, like creating a web service, like creating some compiler stuff. It's something where you can focus on learning the parts of the programming language that you need to know. And to be fair, Rust is not a programming language like any other. It's a very particular programming language, and it has some quirks. It has some things that you have to learn by using it. It's not. I guess it doesn't help just reading about it. So with that, I was able to learn a lot about it. I can recommend it to everybody who wants to get started and that doesn't know how. Try it out. It's free after all, and have fun with it. And also, if the folks here aren't able to give you feedback in time, check out our Discord. You find me there in the random channel asking all the stupid questions, but being very happy that I get all the good answers from our wonderful community. So thank you for teaching me Rust, to the folks in our Discord channel and to the folks at Exorcism. And that's my lightning talk. I was lightning fast. Are there any questions?
Yeah, there are two questions. Cool. Yes, let's give me a sec to get my notes up. Right, yeah, Carl asked if how good is the platform in terms of teaching idiomatic Rust? Not only to teach Rust, but also good Rust, you know?
Yeah, that's a very good question, and especially thanks to Carl, because he's keeping up with my shit a lot once I'm typing questions in the random channel, and Carl taught me a lot of idiomatic Rust and brought me to a lot of resources about idiomatic Rust, because this is not particularly well covered. So you don't get feedback on your solution by folks who know idiomatic Rust until you ask for it through the mentors, which can be a little bit slow. Here you are on your own, and you have to find your resources yourself. One thing that I have to mention is that if you find the right people once they publish their solutions, you can learn idiomatic Rust by looking at other code. So usually idiomatic Rust, and this is one thing that I particularly love about Rust, is you see when it's idiomatic because it looks nice. The moment it's not idiomatic, you have lots of asterisks and ampersands in there, and you think, okay, this might not be the way to use it. You know when you write idiomatic Rust by reading other people's code, and this is where my code got a lot better. So every time I had a broken or solution I was not so happy with, I peeked into the solutions, because this is a trick. If we are here, those are here are the community solutions. This URL does not change, so there's no hash behind it or some ID. If you know what the name of your exercise is, you can find the solutions while you are coding. You don't have to submit it. And this was something where I peeked all the time. So I already knew a couple of images and couple of nicknames there to find some people where I could peek into their solution to learn idiomatic Rust, but they don't focus on idiomatic Rust on their own. What they do is, once you get into the hairy stuff, they provide you with enough resources to read up on that, but that doesn't happen all the time.
Okay. That brings one question from myself as well. Is there a possibility to share your solution, how you solve the problem?
Yeah, so the moment I submit it, I have the possibility to say, let's make it public for everyone who is enrolled. But I guess you have to be enrolled in the course to view it. Let me just try it out by opening my solution for grad school in a private tab where I'm not logged in. Nope, you can share it with everyone. That's cool.
Perfectly.
So if you want to look at my grad school solution, write down the URL right now. I'll share it in Discord later on.
Okay, cool. Yeah, very cool. So there's one last question left. Does Exorcism exist in other languages too? For example,
not other programming languages like German.
In German?
Okay. As far as I know, nope. Not at the moment. So I have the website open right now. I don't think so. So I think it's English only. And I see a question in the Discord channel. It's free. It's 100% free forever. So I guess it's somehow supported by companies so that they can keep up running the service. But the platform is free and will be free.
All right. Yeah. Pretty cool. Thank you very much. So...
Thank you for having me. It was fun. And I'm looking forward to some talks from the pros who actually know what they're doing. So thank you very much.
Thank you. All right. Let's Let's share my slides again just for a couple of seconds because I want to introduce Rainer Stropek with his talk about web APIs with Rust Rocket. Rainer, are you there? I think I need to unmute you. Sorry. First time doing this. Give me a couple of seconds. I'm on to it. Yes. All right. Here it is. Yeah, that should work.
Yes, I am here, and I hope you can hear me.
All right, super. So you're ready?
I am ready. If you stop your screen sharing, I will take over and start with my talk on web APIs with Rocket.
Perfect. So the stage is yours.
So very good. So I think you should now see my screen. I hope it works like that. And with that, I would like to get started. Thank you for having me. I'm looking forward to the next half an hour quick talk about rockets and Rust. My name is Rainer Stropek. I'm one of the organizers and co-initiator of the Rust Linz Meetup. And yeah, with that, I'm already in the first chapter introducing myself. For business, for my living, I do consulting, training work, coding work in the context of cloud computing. This is what I earn money with. I am CEO of a small company which is called Software Architects, and this is what I do. I have learned programming with languages like C, C++, then I switched to C#. I've done a lot of JavaScript, TypeScript code, recently also quite a bit of Go. And I'm not a Rust expert. Just like Stefan, I'm just learning. So this topic came to my mind because I wanted to explore how I could take the things with which I earn money, building APIs and distributed systems, and apply it to something that I'm very interested in, Rust. So what you can expect is you can expect a look at the Rocket framework from the viewpoint of somebody who has seen quite a lot of API building platforms and other programming languages. Please don't expect somebody who is a Rust expert, because I'm not. Probably many of you will see things that I did not so well. So please point it out and let me know whenever I do Rust mistakes. So what is the agenda? We will immediately, after this quick introduction, dive into demos. We will just do demos. I will just show you code, and we will walk through very basic things and then build our way up to, let's say, some kind of RESTful web APIs, but very simple ones. My goal is not to do a complete overview about Rocket. The Rocket framework is much too large. So see it as a kind of teaser. I want to make you excited. I want to fascinate you for this framework, so you take a look on your own and you dive as deep as you want and you need. And with that, as promised, I am done with the introduction. It's demo time. Now we will switch away from the slides. And whenever I show demos, of course, I always share my demo code. And you can see here the link. I can also take this link and put it on Discord if you want to take a look at my code later on, because we only have 30 minutes. So it will be quite a quick ride. So let me quickly switch to my development environment here and open my notes on the other server. That's good. Now we are good. Here, I have created a small little demo application, and currently it's completely empty. And I would like to turn this one into a Rocket Web API. And of course, the first thing that we need to do is we need to add dependencies. And for that, I have created a small, that's the wrong one. Doesn't sound good. So this one. I created a small snippet, and here you see that I can add a dependency on Rocket. The current version is 0.4, but there is one big problem here. If you run Rocket 0.4, you cannot run it with Rust stable. You have to use Rust nightly. I didn't like that very much, so I tried to switch to the Rust stable version, and it turns out it already works, because the main branch of Rocket is already capable of being built with Rust stable. It will come into the crate with version 0.5, which is not done yet. But if you would like to work with stable now, you can do that. Just remove the original dependency here. And what I've created for you, I have created for you the Git dependency. Here you see the Git dependency that you need. And if you depend on the master branch, as you can see it here, you can already work with the stable version of Rust. You do not no longer need the nightly version of Rust. This is brand new. This is not included in the documentation, but you now heard it, and maybe that increases your trust into the Rocket framework. Okay, I've added a bunch of other dependencies that I will use during my talk. Good. Next one. Now we have the dependencies, and we will go into main.rs. And the first thing is I will add a bunch of use statements. I have to go up. Let me see. So we start at the very beginning. Here it is. I have a bunch of uses, and we don't need them yet. So I can just fold them because it's not that important taking a look at all these use statements. This next thing that I need to set up is I need to set up a very basic REST API, a very simple HTTP GET. We'll take a look at that in a second, because the next thing that we need in order to get rid of these red squigglies, we need to add the launch function. Now let's take a look at these first methods, because I think they are important to understanding the basic principles of working with the Rocket framework. As you can see, we don't have a main method here because that is generated out of the box. Instead, we use the launch macro here, and we provide a Rocket function. And here we say Rocket ignite mount. And here with this mount, based on the API namespace, so all my URLs start with /API, I can add a bunch of routes. Now, what is a route? A route can be seen up here. A route has here the HTTP verb that you would like to use, in this case, get. And I'm just answering on /API, nothing more, nothing less. You can return immediately just a string. Essentially, you can return any kind of basic data types because all the Rocket framework implements the so-called responder trait for all of the basic data types like number, string, options, result, and so on. And this responder trait, you can take a look at the details here in this link, it tells Rocket how to serialize this basic data type and how to return it using an HTTP response. So this is why in simple APIs, you can just return a basic data type and it just works. That is good. So let's run this guy. Let's do a cargo run. Let's see if it works, if I didn't screw up. Looks good. Cargo came up. You see here, we have our Hello World API, and I'm currently listening on port 8000, and I've prepared a bunch of demo requests. Let's fire up the first demo request, and woohoo, demo works fine. We already get something in response, and we also see a little bit of demo down here. So the simplest version of a REST API, of a web API written with Rocket is just a single line of getting started, a bunch of macros, and a single route when we just give back a basic data type. Of course, we can also add tests. That's something that I'm already always interested. Let me please add me tests.rs, not TS. I'm not using TypeScript here. I'm using Rust. So that's okay. And here I prepared a small, so here it is. This is the basic launch. And here I have my, no, that's the wrong one, sorry. This is the right snippet. This is how a typical test looks like for the Rocket framework. What you get is a client for local HTTP requests. And with this client, you can just issue a GET request like that. And you can use assertion to take a look into the details. So in this case, I'm just checking whether the response turned into a string is hello world. This is what a typical, to be honest, a very simple test could look like. So let's add the test annotation here. This one. And with that, we can give it a try and run a test. Cargo test. This will automatically here. Oh, okay, get rid of that. Sorry, mistake in the code snippet. Now the test runs and it works fine. As you can see, we now have a very simple route. This route was run by Rocket, and we did a unit test or an integration test by sending a GET request and checking whether the response was correct. In the repository that I mentioned before, you have a bunch of tests that you can all take a look at. So I have added, I think, 7, 8, or 9 more interesting tests, not the super complex ones. They're all beginner ones. But if you are interested, take a look. Because of time limitations, I will not add all the tests during my upcoming demos now, because I want to focus on how to write APIs with Rocket instead of just taking a look at tests. Okay, but it is in the GitHub repo, so take a look at it. I hope you find it interesting. With that, we will continue with our main.rs, and I will add the next snippet. This is a dynamic path route. As a web developer, I have learned that it is super important to have a powerful router inside of your API platform because, well, as a web API designer, you live and die with your router because that is your user interface if you want. What you see here is the first dynamic route. Let me quickly draw a little bit. Here you see name, and here you also see name. So what Rocket does, it takes the name of the route here and inserts the data that you get through the route in the variable. It's important that the routing is also done based on data types. So here I have a string, but this could also be something like a Boolean or any kind of number or something like this. And then the Rocket framework will check whether the value in the URL can be turned into the corresponding type. If it can, the route is taken. If it can't, then the next route is taken that matches the pattern. If there is none, you get a not found error. So this is important, and if you want to know more about how these dynamic paths work and how they consider the type system of Rust, you can take a look at this URL. I added all the URLs here in the documentation. Let's give them a try. Let's add the new endpoint greeting here to our list of mounts, and let's get our cargo running again. It should be done in a second, and here we are, and let's take a look at the requests again. As you can see, here we have the API, and here at the end, we have Reiner, and if I fire that up, it says, hi, hello, Reiner, and if I say foobar, and I send it again, it says, hello, foobar. So, as you can see, if you take a look at the code, it works perfectly fine that we got the name here, the name went into the parameter, and the parameter can be used inside of the method. So this is exactly what we want from dynamic paths. The next thing that I would like to show you is query strings. I will skip over the tests. You can take a look at it. Query strings. Of course, you can add query string parameters too. Here you see a typical route with 2 query string parameters. On the one hand side, we get the name, this time not in the path, but in the query string. And the second query string parameter is salutation. The important thing here is that for salutation, I have used a more interesting type, the type option. So this is an optional query string parameter. That's the important thing. So I can apply a Rust match statement here in order to turn it into a proper greeting. What happens behind the scenes? I asked myself. And the answer is that for all these types, I mentioned it before, but now I want to go into more details. For all these types, Rocket has traits, and it has implemented the from param trait for this type. So if you have your own type that you would like to receive through the query string parameter, you can implement the from param trait for your custom type, and then you can immediately use the existing mechanism of the Rocket framework to consume your type through the query string. If you want to know more about how to implement the from param trait, please take a look at this URL. You will find nice parameters. I think this is the place where I should also give you a warning. If you take the code that I show you here and you run this code or compile this code with the existing crate 0.4.x, some of the things that I show you here will not work because in 0.5, there are some breaking changes. So if you want to recap what I did here, you need to, at least at point of recording this video today, you need to use the master branch from GitHub in order to run all the demos that I do here, okay? And the documentation, unfortunately, is not done. So some of the documentation is not correct, but my samples hopefully work with the latest version in the master branch of Rocket. Good. Query string parameters. Let's give it a try. Let's add a query greeting endpoint here and restart our web API. It launched. Let's go down here. And as you can see, hello Rainer, it ends here. Hello name Rainer leads to hello Rainer. And if I add a salutation to, you see here, I have the salutation hi. And with that, this hi now resulted in this parameter here, in this response here, can be seen on the right-hand side. So our query string works pretty nicely. Let's fill this up and let's go right into the next demo. We have taken a look at various options that you have with dynamic paths and query string, and now I would like to show you a concept of Rocket, which was pretty new for me. I wasn't used to such a concept from other frameworks that I already knew. For this demo, I will create a new file. Let's call it API key.rs. And in this API key, I will add, let me see, a custom request guard. Now, what is a request guard? Let me clean up here a little bit. Let's maybe put it here. A request guard is, at the end of the day, here you can see it, a trait, an implementation of a trait for a custom type. So in my case, I want to implement a so-called request guard where I extract an API key from an HTTP header that I get into my route, into my mounted route for Rocket. And then if there is no API key, I would like to respond with an error, HTTP error. If there is an API key, I want to make this API key available to the implementation of the route so that they can take a look at the key and take appropriate measures. For instance, I don't know, doing some authorization stuff or whatever. It's a very simple implementation, granted, but I think you get the idea. With things like that, you could also implement more elaborate security scenarios, like checking a JWT token that you get from an OpenID Connect server or OAuth server. All these scenarios are possible, and they are not done like I was used to from other frameworks with middlewares, but they are done with request guards. If you take a look at the request guard, I will not take the time to take a close look on every line. So please check out the GitHub repository if you want to have more time. Essentially, you will get the point here. Here, I check whether we have an x-api-key header. And if there is, I'm using base64 decode to decode it from base64. And if both things work, I here construct my custom type, my API key, so that it can be given to the route that you will see in a second. In all other cases, I will respond with a failure, so the request guard will prevent the request from entering into the implementation of the route. So let's add this one into our API. For that, I will add the route with guard here. The route with guard is very simple because the only thing that you need to essentially do here is you need to add a parameter of type API key for which we have implemented the from request trait. And because there is this from request trait, my request guard is run automatically, and only if the request guard is successful, the route is activated. So I can only access this protected route if the user provides a valid API key in the HTTP header. Let's give that a try. Let's add our route here, protected. That looks good. Let's fire up the terminal and cargo run the application. Remember, the /protected endpoint is the one for which we need an API key. So what I have done here is first I have prepared a call without anything. If I do that, I get a 401 unauthorized. Very good. As you can see it here, outcome failure. What this stuff means, give it a second. We still have approximately 20 minutes left. So you will see that in a second, okay? The second one, protected, provides a ready-made base64. Let me show you that base64 decode. It just says secret. That is what you see here. Let me, oh, sorry. Let me encode this again. This is a valid API key. It's just a valid base64 encoded string. And if I run it, woohoo, I'm allowed to access the protected endpoint. And you see the route got the correct API key and can now make appropriate decisions, for instance, based on authorization. If I present a wrongly formatted base64 key, and if I run it again, I also get unauthorized because my implementation of the request guard will return a failure, and therefore the router will not run into the request, but it will return unauthorized because of the return value of my route guard. Nice. So this is a request guard. Sorry, I said route guard. Request guard. This is the concept of request guards. And there are many existing request guards. Let me quickly show you another request guard that I find particularly interesting. And this will make it hopefully more clearer what these things are really used for. Because now I have added the cookie guard. There is a data type which is called cookie jar. And this cookie jar also implements the request, the from request trait. And therefore, it extracts the cookie values from the HTTP request and gives us access, simple access to all the cookies through these parameters. And we can not only read these cookies, as you can see it here, we can also add cookies to the cookie jar. And therefore, we can send a cookie back in the HTTP response. And here we get it from the HTTP request. Let's try that, okay? Let's give that a try by running this guy here. Remember, we have the login method, which just sets a cookie with an arbitrary session key. And here inside our /session, we check whether the current HTTP session has an existing cookie. Let's give that a try. First, I will query the session and I get back, oh, this is already set because I tried it before on this machine. Believe me, if I would start a brand new Visual Studio, we would see that there is no session yet. But I can show you the login, hello login, where, no, I did something wrong. I cheated. I did something wrong. I simply forgot to add here the login and the session route. I'm sorry. And now, if we are lucky, I don't have a cached cookie yet, and I can really do the demo as intended. The server runs. First, let's try the session. You got the key. Yeah, it's already cached. I'm very sorry, but imagine here you see you don't have the cookie, but in this case, it was just cached from my previous experiments. But if I do log in, everything is fine. And you see here that really a session cookie is returned. And this is the session cookie that I have created through these cookie jar. And with the request guard and the from response trait, another trait which is responsible for turning the cookie jar into a response message with these from request and from response. The combination allows us to set cookies and get cookies. This is provided by Rocket out of the box, so I didn't need to implement anything for this cookie support. Nice. Next one. The next demo is a little bit larger, and we are good in time. We have approximately 10 minutes left, so that we have at the end a few minutes left for questions. And the next demo is a little bit larger because I want to implement a simple REST API with a little bit of post, a little bit of get, and things like that. Let's start with adding a small region where we can now add our code. The first thing that I would like to add here is some types. Let me show you these types, and I will zoom in a little bit so you see it better. I want to maintain a list of heroes, and I have implemented, oops, sorry, I didn't want to do that. Now, this is what I wanted to do. I implemented two structs here. The first one, hero, is used for returning heroes from our hero database. I'm not using a real database here, just in memory stuff. The second struct that you see down here, the new hero, is used to receive through the HTTP request body to receive a request to create a new hero. This is why for the hero struct, I implemented the serialize the 30 serialize, I use the 30 serialize macro here. And here I use the deserialize functionality because this is what I want to receive. So I get the JSON and I need to deserialize the JSON in order to process the data of our new hero. The serialization and deserialization is done by 30. So this is done by plugging in the 30 crate into Rocket. This is not a functionality of Rocket. Just to prove the point, if we take a look at cargo toml, then you will see that I added here 30 and yeah, that's it. So with that, we have our data modal, let's put it that way, and we can add our repository. This is a very, very simple implementation of a repository. Here, I'm just using a hash map, as you can see it here, a hash map of ID to hero, and I protect this hash map with a reader-writer lock. I also use an atomic usize, and we will learn a lot, I suppose, from Stefan about this topic, so I will not go into the details. I'm using an atomic usize value here in order to generate a unique hero ID. This is what I do here. The important thing that I want to give you, that I want to tell you, is that that Rocket has specific support for storing state, not just in memory hash maps, but for storing state in databases. Databases like Postgres and so on are supported out of the box. You can also combine Rocket very easily with the Diesel OR mapper, and for instance, use Diesel as your OR mapper to store your data in a Postgres database, and everything nicely integrated into the Rocket framework. Unfortunately, I don't have the time to go into that specific feature. I only have 30 minutes. So the only thing that I can do is I can point you to this URL if you want to know more about how you integrate Diesel with a database like Postgres and a bunch of other databases that you can look up in the documentation. With Rocket, take a look at this URL. You will find all the details here. Now, next one, let's now implement the add function. Let's go through the code here. Here we have our add hero functionality. It listens on the /hero route. The format is JSON, which will result in the router only accepting GET requests with a content type of application/JSON. So this is part of the router. You don't have to verify the content type on your own. The important new thing here is the data where I use the name of a parameter. Here you see the parameter where you want Rocket to give you the JSON. In this case, JSON. There is support for forms too, but in this case, I'm using JSON payload from the HTTP request. So it deserializes the data that comes in, and you can immediately access the data from the new hero data type that we created before. You might now ask yourself, what is this hero map and where does this state comes from? What is this hero count? Well, this is what you have up here, but these are only the types. Bear with me for a few more moments. This is a new thing that we will take a look at in just 1 or 2 minutes. For now, just accept that somebody somewhere uses a kind of dependency injection. In this case, it's state injection, where we can say, this is the singleton heroes map that Rocket should supply to any method requesting this state of this type. There is not just global, let's say singleton states, but there is also request local state where you can, for instance, share certain state information across multiple functions, middlewares, and so on, across all these things. But these things are request local, and when you get a new HTTP request, you get a new instance of the according type. The implementation isn't very interesting. I get, as you can see, a new hero ID. I create a new hero here. I store this hero into my in-memory repository. And at the end, I return a created response. The problem with the created response when building APIs is always how to set the location header. And luckily, Rocket has a nice little function here, a nice little helper, so-called typed URI helper, where I can request Rocket to build a response URL, no, not a response, sorry, a URL for the location header based on another route function that we have to still write because we have no get hero method by now. So let's continue with the next two. This one, get hero, and this one with get all heroes. So now you can see how these place together. Here, I'm asking Rocket that it should build the URL for the location header of the created response based on the name of another function. Here you can see it, and based on a parameter. Here you see the parameter. So it will create the proper URL that I can return in the location header. This is very useful. I know this concept from other frameworks like ASP.NET and C#, and I was very happy when I saw that this functionality is available here in Rocket 2. So before we can run this guy, we need to add a little bit here, and this is the magic regarding the global state. Because by adding here these two manage statements, we can add a single instance of the hash map where all our heroes are stored. And I can add a single instance of my hero count that I use for generating a new hero ID, a unique hero ID. And with that, my very, very simple REST API should be done. Let's give it a try. Add hero is the first one. Get hero is the second one, and get all is the third route that I would like to add. Cargo run this guy. This should bring up a new API with enhanced capabilities. And here you see, if I query for all the heroes, you see it here, I will get an empty array, just as expected. If I go up and I insert a proper hero, here you can see it. If I run the post request, I get the created, and here you see the point. You see, I get a proper location header, which points me to the URL where I can later on get the data of the hero again. This is the URL helper macro that I showed you before. Now I can also query this guy by here specifying a dynamic route parameter, and you can see I can correctly query Homelander. If I try to add data, let me quickly get rid of that one. Sorry. If I try to add data which is not correct here, for instance, and if I send this, I get an unprocessable entity, which is a default response that Rocket gives me if the data provided in the body of the HTTP request does not fit to the struct that I'm trying to deserialize from the JSON here. So this is done automatically from my code. Nice. Okay. With that, I only have one last demo left, and I would really like to show you this last demo. The last demo, I called it log fairing. Fairing is a concept, the final concept that I would like to show you today. Fairing is a concept which is very near to what you might know as a middleware from frameworks like Node.js Express or Go or maybe ASP.NET Core C#. It's kind of middleware. It's a kind of wrapper around the whole router and around all the other methods. And in this case, I created a so-called fairing which will create log events, and I created a rather naive implementation where I'm handling, this is the concept of Rocket and fairings, where I'm handling every request, and in this case, I'm just sending this request with request client to a central log gathering service, which in my case is sec. I can show you that in a second. So this here, I can now take it and wrap it with attached around the igniting rocket, as you can see it here. And now this fairing wraps around all the incoming requests, and if the demo gods are smiling, it should then send a message to sec whenever I send a request. Let's give that a try as the final demo, and I hope it will work. Let's cargo run this guy again. And in the meanwhile, I can bring up the sec browser. Here it is. If you're not familiar with that, don't worry. It's just a very simple mechanism. It's just a very simple viewer for logs. And now here on the left-hand side, I will go into my requests and I will fire up a bunch of requests here. Yeah, the requests go through. And now if I refresh this guy, here you see I have now log messages that I got through HTTP. So my fairing logs incoming HTTP requests to sec using sec's REST API. And I wrapped around this logging functionality using a fairing. I didn't need to change anything on the other endpoints that I had in my demo application. I just had to attach this fairing. And there are many fairings already existing in the Rocket framework. And as you can see it here, it's pretty simple to implement your own fairing. All you have to do is to implement the fairing trait. And well, yeah, essentially, that's it. That was my demo. It was pretty fast. I know I only had 30 minutes, but I wanted to finish in time. I hope you got an idea, a rough idea, how this Rocket stuff really works and whether it is relevant for your work. Let me quickly go back to the slides. Here you see the slides. I hope you enjoyed my presentation. If you would like to get in touch, there is a digital CV. It's under rhinostropic.me. And if you scroll down here, you will see a bunch of links. So you can use LinkedIn or GitHub or Twitter or whatever. If you would like to keep in touch, I would be more than happy. With that, I would like to give back to Patrick because maybe we have 2 or 3 minutes time for questions.
Right. Carl gave us 2 questions. May I pass them right to you?
Absolutely. Please do so.
All right. He asked, can you pass a future to the roots? Which I try to understand it the way that he means that can a root be async?
Yes, it can. It couldn't up until a few months ago, but with the version 0.5 or the main branch in the Git repository, async IO is possible. Yes. You can use async. By the way, I was probably too fast, but here you can see, for instance, in the fairing, I was already using async await when doing the HTTP request to the sec log gathering system.
Yeah, and Carl also already mentioned that async is just a synthetic sugar for futures. Is that correct?
You have to ask somebody who's deeper into Rust. I warned you, I'm a Rust beginner. I'm a very interested beginner, just like Stefan, but my journey into Rust has just begun.
Okay. No, just try to connect the word future with async in any way, but
I'm sure Carl can answer this question for you on Discord.
All right. All right. And Carl had a second question.
Yes.
Can I run the Rocket server at any runtime, or is it constrained to Tokyo async standard? Something like that.
I didn't add a dependency on Tokyo or anything else. It's just that's all. You can take a look at the GitHub repository. Nothing special here.
All right. Yeah, I think.
Okay.
Yeah, looks good. Thank you.
Yeah, I hope it was interesting. Yeah.
It was very interesting. Thank you very much. It was awesome because as a web developer, I really enjoyed those session about the web. And I have a small question. Thanks, because Rocket is still in preview. Things it's not should not be used in production so far as I know. That's correct.
Not production, so not version 1.0 does not mean that it is not ready for production purposes. It really depends. If you would like to have a product with a big company behind it who offers support and it has an official going live thing, something like this, then maybe Rocket is not ready for production use, if you put it that way. But if you are looking for a robust system for running your APIs, I would say that Rocket definitely fulfills this request. So it depends on what you see as stable. As you know that with many open source products, it takes many, many years until they really say it's version 1.0, but I would not say that it's not ready for production use. The version 0.5 is not ready for production use. That's correct. So the bits that I used here, they are not ready for production use, but hopefully it will only be a few weeks until you can really get your hands dirty on the new version and get this crate directly from there and not having to create a Git dependency anymore.
Sounds awesome. Thank you very much. All right.
Good. I think with that, I was pretty much in time. I say thank you again. And yeah, I'm looking forward to the next talk.
Thank you very much. Let's switch for a couple of seconds back to the slides. I hope I get the right monitor. Yes, here we are. Of course, this time I want to get it right with unmuting Stefan before I introduce him, because Stefan talks about atomic counters and cache lines. Stefan, are you here?
Yes.
All right. So the stage is yours. I stop my sharing right now.
Quickly set up the whole thing.
Sure. The stage is yours. Have fun.
One moment. Yes, I see. I tried something last minute, and of course it blew up in my face. Here we go. So sharing screen. Okay, let's go. I have to prevent. Oh no. I'm sorry, I have to restart this sharing again. Share. Now it works. Yes. So, okay. Hello, I'm Stefan. Sorry for the delay. Not used to this kind of presentation yet, so we'll see how that goes. Quick introduction. Then we'll go over integer types. So this will be more of an advanced talk. Our MC kindly has an eye on the chat, so please enter your questions there. And then we'll go through some examples, and it will be like, yeah, why do we care, into like the nitty-gritty details, into an actual application. How can we use that in Rust? And yeah, so about me, I am currently studying at my master's. Started with Rust 5 years ago. I'm also organizer of RustFest, give some talks every now and then. If you want to watch the RustFest talks, you can do so at watchtherustfest.global, or in a couple of weeks, maybe less, you can watch them on YouTube on your favorite Rust channel. So, what's topic two? We have to differentiate between memory and symbol. What's a symbol? What's variable? What's a register? What are atomic operations? And what's the visibility problem? And also, what is a CPU cache? Why do we have it? What is a cache line? Before we begin, yes, most people come up to me and are like, yeah, Rust is pretty cool, but it's too slow. And I'm just like, have you tried release mode? So that's one thing that gives you a speed boost of at least factor 2, usually factor 40, sometimes even more. And that's important because you don't have to optimize, right? You just tell the compiler, do it, do optimize for me. Another thing I like to run is Cargo Watch. You can see it on the second line. Cargo Watch watches all the files in your project. It watches the source and static and all the other folders. And whenever you change one, it waits a little bit, I think it's 0.5 seconds or something, then it runs these X commands. And these are equivalent to you typing in cargo check, cargo of FMT for format, and cargo run. And of course, you can add quotes around the run, and then it's run -- release in quotes, and it will run in release mode. Why is that important? Link time is really bad in Rust still. So if you have a huge project with like 300, 400 dependencies, which you get to that point really fast if you use ActX as a web framework and maybe some image libraries for image processing, then you have another image generation library for these little fancy icons. And then you have a database and maybe database pool and maybe some WebSocket handling and whatnot. And then after all that, there's your game logic. That's like 300 crates into the build process. So cargo check is really fast because it does not link your project. It checks the syntax, it checks most of the types, and then it tells you if you're okay or not. And that's great. Format keeps your code clean in the sense that it has one kind of format. That's really great for working together with people. There's nothing worse than looking at someone's code and just not having a feel for where the control flow is going, just because they have some uncommon indentations and whatnot. If you're coming from C-like languages or JavaScript where brackets are optional around the if or the for loops or the while loops, then you know what I mean. It's horrible, right? Because someone can write stuff like if, for, and then one statement, semicolon, and then another in one line. And then you have to remember that the last one is not included in the if or the for loop. Leads to really, really dirty bugs. Moving on. So why do we care about atomics? I've given you here LS topo of my machine. It has 24 gigs of memory, 4 cores with 2 compute units. And you see it's pretty powerful, and that's a laptop. So to make problems solvable, we need a lot of compute power. And Python is great for teaching algorithms and whatnot. But when it comes down to raw compute performance, we want to be able to leverage all these 8 cores or whatever we have. I mean, I've worked on systems with 128 cores. So it would be a shame if you only use 1 or 2 of them. So how many times do we need integer data? And most people think like, yeah, we'll work with strings or tables and databases, but you can do a lot with integer data. One of the big things is counting stuff or indexing stuff. So even if we work with strings, indexes have an impact. Now, if we have multiple objects in a list, in an array, or in a vector, we need to be able to calculate these indexes fast and have fast access to the stuff. So this is a quick question, and let's see if we can make this work. I will try to open the chat myself. Rust Linz. I don't think I've seen any suggestions where will the index be stored. So let's resolve that. These are the answers. So the index is size. It's not on the stack. Thank you, Vladimir. Just seen you. Index has type usize because that's where the data index brackets. That forces the type into usize, and because we operate on an index level, it actually lives in RSP. It's a register. So that symbol does not have a memory address at runtime. And because LLVM is pretty cool, the data will get analyzed. By data, I mean the program code will be analyzed, and then the compiler decides, oh, it's just 4 loops, right? It can determine that it's just 4 loops from that control flow, and it will say, too bad, we will unroll that. So you don't see this loop in the assembler anymore. And that's pretty powerful. We don't have to care. If we run this on a really small ARM machine, this will give us a huge improvement, because it doesn't matter what the ARM machine is. There's no more index calculations. It's just like jumping into the fields and reading it out. Where's my moving? There we go. So what happens if we want to watch a value from another thread? Like something is happening over here and we want to watch it and react to it. So let's make a scenario. So we have 2 threads, a counter and a watcher. And we will set these up with the control thread that's running in the main function. And it's basically what it says there. The counter will just loop around. It will count from 0 to 99. And the watcher thread will try to count how many times does it change. Like every time the value changes, it will increment itself, and it will record to us how many times it was able to observe the same value. And one would expect to have this one-to-one correlation, right? Because this one increments by 1, this one sees it and also adds 1 and follows suit. So this is our code. If you have been using Rust a lot, you probably see the notes here. This is directly from the example. So you can run this code after the talk. The last example I have to upload still, so that one will be available soon after. Unsafe, as I wanted to say, is here. This is a sign that you have to be really, really careful, and you should add a note why this unsafe is safe. And as we will see, this one is not. Moving on, the watcher thread. It waits a little bit at the start. It waits for 500 milliseconds just to give the operating system a chance to like set everything up. And the other one is like a clock, right? It goes round and round and round. It doesn't really matter when we will start observing. We'll just, if we miss it by 1 cycle, no matter, we'll just go. And also here, to be able to read the threshold value, we have to use an unsafe block. Another thing you have noticed, if we didn't copy it into threshold local, we would have to fetch it from the memory all the time for every time we access threshold local. So this is another hint that this is probably unsafe and probably not so stable as we have it here. We have no comments, not great. In production, if you use unsafe, always write a comment for the next person. And even if that next person is you in a couple of weeks, explain why this unsafe is necessary. And maybe in a couple of weeks, you'll revisit this code and say, I can make this safe now and never have to worry about this doing weird stuff. Also, threshold local is in the register again. So, okay. In the main thread, after the watcher has observed, I think it was 100 or something samples, it will print how many it has recorded, and then it will also print the last part of the history, so we can see how big the runs are. And yeah, as I said before, one would expect naively that this would be like a small number, and more importantly, a constant number, like maybe 1 or 2, because it's simpler to watch a value than to write the value. But this is what we get. We get 88, and then we have observed it once, and then we get 93. We have observed it once, and 98. So observed it just once. So this 0 is how many repetitions we have. And we wanted to have, I think it was 100,000 samples, and we only recorded 99,000 transitions. So this is like all over the place. But now we think, yeah, maybe it's just too slow, right? Maybe it misses it because it's debug mode, and debug mode is slow. So let's put it in release mode. This is even worse. Now we don't see any transitions anymore. And you can guess now why, and I will go back to the code of the watcher thread. Why is this not recording any changes anymore? Having a sip of tea. Patrick is typing. Also, someone has posted the unroll crate in Doxorus. So I don't see any one proposing any answers. Anyhow, so the main problem is the compiler looks at this from a single threaded point of view and says, this thing here is a symbol that we see out here. And yes, compiler optimization, Matthias is correct. So this one is a local symbol. This one is always the same, so we don't need this update anymore. And then this value will always be the same. So this is always true. So we can just increase the counts. This branch here gets discarded completely. And then we have max test, which just contains a count increment. The compiler is smart enough to transform this loop into just assigning the max value to count itself. And then it notices, oh, count is never read actually. So it doesn't need count anymore. And then we see last isn't read either. So we don't need that anymore either. History, yeah, we still need that. We need to allocate that thing because the user forced me to, and then we have to give it back. And that's the end of the story. So the only thing that survives this is a huge allocation and a return statement. Not very obvious in this small code, and it gets even worse in bigger code. So yeah. So let's fix that. So we have the counter function, and we say, hey, compiler, don't optimize this away. Yeah, Vladimir just wrote in the chat that Rust needs the volatile keyword, and we don't. We really don't want the volatile keyword. It's badly designed. It does mean different things in different C versions, and it does mean different things in C++ and in C, although the same compiler compiled that code. If we actually need volatile, then we have this read and write volatile pointer functions. And we can actually do stuff like that. And in this case, we don't get optimized away because the compiler knows, yeah, we have to touch the memory. Therefore, we have a side effect. And this has to be like attributed to something. So this will actually write to the memory always. And then we get somewhat correct numbers. Oh, there's some slides missing. I'm really sorry. So on the next slide, there should be something. Hot fixing slides during talk. End frame. Why is this broken? I'm really sorry. I have to read you the numbers from the source code because there is an entire segment missing here. Let's see. Oh, no, it just reordered. Okay. Never mind this chapter. we have some weird reordering. I'm sorry. Now I'm confused. Okay, let's trust the slides. So now we need atomic operations. Really sorry for messing up LaTeX. So atomic access is stuff that appears to the user of the CPU as one thing. Like we cannot differentiate half access and whatnot. There are some optimizations for that. That means we have to pay attention to caches. We can do misaligned access, but it will be very slow. This is especially true if we have bit flags that we have to check, because we have to fetch and load the whole block and then access the word and then have to perform and or operations onto the thing, and then we get the bit we want, which is terribly inefficient. So another thing that most people are not aware of is that atomic operations also have effects on memory reordering and instruction reordering. And to make sure that this works properly on every CPU is very, very difficult, because it's different. It's different on AMD 64. It's mostly the same on Intel x86 64, but it's different on 32-bit, and it's definitely different on ARM. Depending on what ARM it is, it's very different. Sometimes we have reordering in the CPU, sometimes we don't. All of these things we have to keep in our head all the time we compile the program. So why not use an abstraction? This is the same about the lock prefix. So these are the most important thing is actually the fat keywords down there. These are the assembler instructions that will behave differently with the lock prefix. And the lock prefix is what our abstractions with atomic variables and pointers and counters use to actually work for comparison, increment, decrement, not sub, whatever. All of these operations, we need CPU support. The hardware has to guarantee atomic execution. And on AMD 64, it's called locks. But on the other on the other instruction sets, it's different. So, oh yeah, I almost forgot about this one. We have very different guarantees. So on Intel is very optimistic, and everybody has heard of Spectre, I assume, and other side channel attacks. And it's buried in this number, how many cycles does it take? One cycle, for instance, if you increment one number single threaded, it's one cycle, pretty fast. Atomic operations, 20 to 120 cycles. It's not great, but it's still okay. The trade-off is worth it. But since Intel was not able to implement AMD 64 instruction set back in the day, they emulated it. So the CPU that is running Intel, Intel CPUs are not running instruction sets in hardware like AMD's are. They are actually virtual machines that emulate the CPU and behave the same most of the time. That's why we need microcode updates all the time, because Intel makes mistakes and they have to be fixed. AMD Opteron is the last platform I was able to get solid numbers from. It's 40 cycles for every operation. Very deterministic, very nice for everybody that relies on real-time systems. For the Ryzen and EPYC, I haven't been able to get solid numbers, and I haven't had the time to measure it myself. So, but it will be roughly in the same neighborhood, if not better. So let's do a counter race again. So we have 100K increments that we want to do. 4 parties, and we want the 4 parties to increment this global counter. Const is super, because the compiler can insert that number into the various places. And static means it's one field in memory and everybody knows where it is and will just write to this field. So, for those of you that are new to Rust, this is more functional style. I'm really sorry if you're confused by the thing. So let me go quickly through the thing. So, for symbol and then in. So we can do ranges. If you come from Python, for instance, you can say for x in range colon, and then it will iterate over this range. This is the same thing. This is the syntax for it. One number, dot, dot, and one other number. We can also have inclusive range. Then it's one number, dot, dot, equal, and then the other number. Brilliant. Why do we need brackets? Because if we put this dot map here, it would go to the second number. We don't want that. We want to have the range. And then from this range on, we want to map. So range are iterable. So this is a for loop. A for loop. And then we use map. And then this I. And this I transforms with this function into whatever we want. So we have underscore I, so we ignore the value. So we just want to have a for loop that runs as many times as we need. And then we spawn threads. This is the closure that we spawn. Inside the closure, we get the counter pointer because we need that. And then we use read volatile, this was read volatile to get the current value, increment it by 1 locally, and then write volatile back into the thing because we know where it is and we can do that. And it's unsafe because you shouldn't do that. So this is our setup. This is our spawn handlers. And then we use collect. Collect means everything that has been generated by the previous iterator, so these handlers of these functions, now we collect that into a vector. And because we cannot actually, well, in this case we can. This one is just laziness. So I don't want to say what exact type this is. This would be join handler of a function that returns something. But I don't have to. I can just say underscore, figure it out, compiler. I don't care. And then we use this little handy dandy thing. It's called into-iter, which takes a container, an existing container, and iterates into the thing. Why do we do that here? The reason is we need to buffer all of the jobs, because if we don't buffer them in this vector, then we will just spawn one at a time and process them just like in order, so they don't run concurrently. We don't want that. So start all of them. At this point, all of them are started. And then once everything is started, we'll loop over what we have. And then we say, okay, for each, we wait for the result. So we'll just wait for the first one, the second, and so on. And then, yeah, that's it. Because we operate on the global thing, and then we can ask ourselves, how big is it? So we'll have to calculate the pointer again with this. And then we can just read it, read the pointer, read volatile, and say, okay, what we expected is how many parties we had times how many increments we wanted to do. And ta-da. The result is pretty bad. It's way off. And the reason for that is sometimes, actually most of the times, because we're pretty close to the lower end, all 4 threads read the same value, do the same calculation, and write back the same value. If we're a little bit lucky, they get a little bit out of sync, and then the value starts to increase a little more than one thread would have done alone. So let's fix that. Let's use atomic usize. It's the same code, but instead of pointer magic, we just tell the Rust compiler, figure it out, make it work on this hardware. And we say fetch add, and then this one is new, ordering, and I will get into this after a sip of tea. pardon me. Oh, I haven't spoken that much in a long time. I also see Carl has the perfect reaction. It says, it's fascinating, but way too low level. I agree, for most people, this is probably true. Moving on. Ordering. If you come from C++, they introduced the concept of ordering because there are different trade-offs when you write to stuff. For instance, there is, you see this at the bottom, sequential consistent. This means we don't want memory reordering and we don't want instruction reordering. So at that point, when we load this thing, every code that has been above this has to be finished. Every memory read and write has to be finished at that point. That is great for stability, but it's pretty bad for speed. How bad, I will tell you later in the measurements. On the other hand, relaxed is fire and forget. So what you tell the CPU chip here is, yeah, it doesn't really matter if I get reordered, as long as you don't lose the increment I'm doing. And that's all the magic. There's acquire and store as well. So this means you don't care about, these are like the two extremes, like relaxed and sequential consistent are the both ends of the spectrum. And in between, there is more where you can say, I care about all the reads before the thing I do. And then there's one that I care all the writes before I do. And then there's one where I care about most of the read and writes before, but not about the location in instruction reordering. These are details. If you get into that, hire me. I mean, I have time for a project, just studying a master's degree. All right. And now with fetch add and load, we get what we wanted. We have exact store. The runtime is comparable, if I remember correctly, but I don't have the numbers here. So that's what we should do. Also, as you may have noticed, we don't have unsafe anymore. So it just works. By the way, if you're using a more recent compiler, atomic USI init, this constant has been replaced by const generics code. So you can specify a certain number at compile time. So we don't have to have an init function that runs before our main that then sets the atomic value to a certain thing if this value is not 0. So we can just write it into the code and put it to 42 or whatever we need. So cache lines. So why was this so, why did I build up to this? Oh, there's a question in the chat. So not Matthias says, what's the difference between the atomic group and mutexes? A mutex is a pretty complex thing, which you can build out of atomics. So what you can do is you can have an atomic counter and an atomic pointer, which is, let's be honest, basically the same thing. So, then if you want to access the mutex, you increment the counter value of the mutex and say, hey, this is me now. I want to access the thing. And then you have to check again that no one else has changed the mutex. And then if not, you can access the value safely. And when you unlock it, you can decrement the counter. This lock is a really bad one. So the real mutex is a little more complex. Also, this is relatively slow. But if we don't have an operating system, that's how we are going to operate. We have to have an atomic linked list. Linked lists in Rust usually really bad. So this time, yeah, we need it as a queue. And then we have this atomic queue where everybody that wants to acquire the mutex has to operate on this atomic queue. And then we have to create these data structures, add ourselves to the list, see that no one else has manipulated the list in a way that we don't like. And then check if we're at the head of the list. And if we are, we can access the value and manipulate it. And if we are done with the list, we can remove ourselves from the list and point the thing to something else. And then we have to actually wait for a bit until hardware flushes out the cache information, and then we can free the thing. Otherwise, we have a use after free potentially in another thread. And if you think this is insane, who would write such a complicated thing? That's actually how the Linux USB driver stack works, with just writing stuff around in memory and waiting a little bit in the hopes that no one has access to it. And then there is a value in the documentation. If you acquire any structure from the USB kernel driver stack inside the kernel, you're allowed to hold it for, I think, 4 seconds or something like that. And then you have to let go. Maybe it's less nowadays. So yeah, the point being hot plug is hard, and doing that stuff in C is harder, and that's the solution they came up with. So, oh yeah, before we move on, there's another cool crate called Parking Lot, and that leverages operating system support. So what modern big CPUs can, so the bigger ARMs and the AMD 64 CPUs, and also the big Intel ones, of course, they have memory areas that we can add callbacks to. And if we access them or write to them, we get a trap. So that's a thing that we get a virtual interrupt from the CPU, and then we can react to that. And that technique can be used to build mutexes. They're called futex, that are faster than the traditional mutex because we leverage the hardware support, but doesn't work on all platforms and usually requires operating system support. But it's really cool and it's really fast. Look into Parking Lot if you're interested. So, cache lines, taking another sip. Our CPU is great. Let's be honest, it's a marvel of technology. Whenever you think computers are shite, think again. Think about how many things a CPU can do, how fast it is, and with what dumb instructions we have to feed it, and it still makes stuff fast, right? You can, I have spoken to a professor a couple of years back where he said like, yeah, it's no fun with these modern CPUs with the instruction reordering and the memory reordering, because even if you have the worst assembler code, these new back in the day i7, this new i7, so this was what 2010-ish. These i7s are bad because they reorder your really bad assembler code and make it performant, and you don't even see why. So there's no point in optimizing assembler anymore. And there's just like, yay. So they actually canceled that class because the last time they had hardware that was old enough that would not do instruction reordering and memory reordering was with these old 8086 32-bit CPUs, single core, really old. Like they don't need a cooler. They are that old. They're like this big, like a AAA battery, and they run at I think 80 megahertz, but that's already overclocked. So default clock is 40. So focusing back, I'm sorry, because otherwise this gets too long. So we have one NUMA node in my machine, or bigger machines have multiple. We have L3 cache. This is the cache that the latest Ryzen generation has a lot of, like I think 16 megabytes instead of 4 for a laptop CPU, which is great. It improves performance. Then we have L2. We can see here our core complex has 2 PUs, and these two share one L2, and then we have an L1 data cache and an L1 instruction cache. That's important because the instruction cache with programs that are linear in flow, like have this instruction, that, they feed a lot of instructions while the data stays mostly the same. On the other hand, if we have a program that is fast but runs in a loop, like for graphics calculation. Instructions are usually the same, but the data gets fed through really fast. So we need to have these two caches that are independent, and the data cache is smaller in my CPU. These caches grow with every generation because usually it's the easiest way to improve performance by 10-ish% if you double these caches. And that's what manufacturers will keep doing, because clock speeds are at the limit. We cannot go above 5 gigahertz without super special cooling. I've seen some sub-zero cooling now, but let's be honest, if we waste 500 watts on cooling solution and then another 300 watts on our CPU, that just blows our energy budget for everything. So we cannot use that. The solution is more cores, as we see with this laptop, and bigger caches. Moving on. This is a more colorful diagram. This one's from AMD. So we see the instruction cache here, and this one gets fed by branch prediction. That's what I said with instruction reordering. Instruction reordering is before that. Then is branch prediction. So the CPU actually calculates both branches of your if, and then does operations caching, and then micro op queue. So this means AMD also starts using virtual infrastructure inside the CPUs. It's faster, but I really hope they don't overdo it, because in the end we will end up with Spectre on AMD and Meltdown and all these not so fun things that will make our lives really, really, really bad and compromise security at the end of the day. There's also a chance that there will be a new command at some point where you can just say, from here on out, stop optimizing. Just be a dumb CPU, even if we lose performance of 40% or 50%. We don't care. We don't want anything weird happen until there's this other flag that comes on and says, yeah, from now on it's application code. It's not security relevant anymore. You may optimize and decode in any in any fashion you want. Also, what's not shown on this diagram is the decoder and the op cache. They instruct the memory prefetcher. So the prefetcher will actually fetch memory that's not used by your program yet, but the algorithm is like, yeah, there's a good chance it will be used soon. So let's fetch it from the memory, because the memory is really slow. Another fun fact, for the CPU, this part that we see on this diagram, the cache is mostly transparent. So it does not see the difference between L1, 2, 3, and memory. Just operates on the thing, and the memory prefetcher will fetch stuff from the memory over L3 into 2 into L1, and then the actual compute units, the orange and the red here in the middle, will then do their work. There's other compute units, and this would be another talk on what you can and cannot do with all of that. So, measuring this, it's insane, right? So many things. It's just between two instructions, and you usually never have to think about it. But one common thing is, if you have performance counters, you may use them with what's its name, Prometheus, right? There's a Prometheus crane. We can say, okay, here is a bunch of counters. I want to measure, I don't know, how many requests I get in my web server per, I don't know, second, or in total, maybe per route, right? You have the main page, some API call, some other API call. Then you maybe want to measure how much time does it take to fulfill all these requests, how many are authenticated, all of that. That amounts to a pretty significant number of counters. And now we'll dive into what happens if we store these numbers too close to each other. Yeah, so let's build a test. By the way, this is the test harness. This is built into Rust nightly. You can create a file. Let me quickly show this to you. Why is this not working? So we have our project here. Oh, by the way, this is Exa for the people that don't use it. It's very colorful. And then we say in this Rust toolchain file, nightly. So that means all the cargo commands that we issue will automatically get redirected to nightly. If we exit this folder and use cargo there, it's whatever else we have. In my case, this is stable. So I can recommend that for measurement projects like this, just as a side note. Black box is a really handy function because it tells the compiler, don't optimize this away. Like, don't touch it, just treat it as random input output. We really need that. And we have a different between relaxed and sequential consistent. I will show you the measurements afterwards. Yeah. There's some unsafe magic because I'm using some trait magic to swap out the things I want to show to you. Let's see if I can show you the code real quick. What source main. So this is the trait, these are the counters, and then these are the tests. They're called bench. And I have this type argument that then gets matched by a constructor, and then the work gets done. So moving on. Each structure has 8 fields because I designed this test for up to 8 CPUs. I only have 8, and yeah, just increasing the number by the alphabet is a boring task. So A is 0, B is 1, and so on. Normal is just atomic useizes all the way. Then we have alignment. So we align the whole structure by 64 bytes, pardon me. That means we will start at a cache line, right? So when the compiler allocates space for that thing in memory, it will start at a cache line. This means it will not lap over some cache lines because the smaller structure may fit in the first half in the first cache line and the second half in the second, and this will cost us performance again. We don't want that. And the third structure is everything is aligned, like the structure itself and the fields itself. So each member has its own cache line. Here you see ... equal from the ranges. So if we just run one thread, it's like 8 milliseconds per execution. That's not bad. And then 2 it gets worse, right? And then it gets really bad. So okay, let's just make sure that it's aligned. Okay, let's align it so it starts the same. But apart from that, there's not much difference, right? So the small numbers change, but the big ones are basically the same. What is if we have cache line awareness? Interesting, isn't it? Right? So we lose hardly any time anymore because the CPU is actually able to access different parts, different caches. And I'm really sad that that's like, pew, fireworks. That's it. If we look at the numbers combined, that's it. In this case, we save a factor of 10 with 8 cores, and that's great. If we have a bigger CPU, this number will only get better. Yeah, I'm really sorry for everybody who's like, oh, and now this is it. Yeah, if we order differently, if we have ordering relaxed, I hinted it before. See these numbers? They come down a lot, like a lot. Because now we can tell the CPU, yeah, just whenever, right? We don't need you to interrupt your memory prefetching And this test is backed by, I think, 100K entries that we allocate an array, one block of memory with 100K entries. And then depending on the kind, we will access them overlapped or in different cache lines. And we actually gain speed a lot. Like, remember this one, the first cache line I were, it's like 8.7 always, unless it's normal. With relaxed, we are faster, even with 8 cores working on these numbers. So the takeaway here is, if you have performance counters, always use ordering relaxed, because otherwise you will interrupt the, I'm sorry, I went ahead to the conclusion. You will interrupt the program flow, the memory optimization so badly by your measurements that you will distort whatever you're measuring too much to have any like relevant data. Yeah, other conclusions. We need atomic operations for many things. There are lots of great crates. Standard library is one of the big ones that abstract away all of these things. It frees our heads from the burden of thinking about all of this stuff. I think most of you heard about this stuff for the first time. Just be happy that someone else took care of this with an abstraction. And you can manage other problems than like running around and handling individual threads. Just use a pool, or think about which hardware capabilities your program has to use to be able to run or not. The compiler will just tell you. And with that, opening to questions. Yes, Patrick.
Hello. Yeah, there is still one question. You already answered a lot of them, but not Matthias still has one question.
Yes.
Is there any reason to not cache align everything? I guess the performance will drop when doing that. Do you have an opinion on that?
I can answer that question. So my demo project here has, let me make this a little bigger. It has also a normal run mode. Actually, I should be a good citizen and show you the release mode. So this is the size. How big is everything? Atomic use size, 8 bytes, right? 8 times 8, 64 bits. That's what we expect. If you align the structure like 8 fields with 8 things, then it's 512 bytes long. So it's half a kilobyte for one data structure. And the others that are normally aligned are just 64 bytes. So that's the trade-off, right? We trade space for speed.
Right, yeah, makes sense. It's pretty cool. I really loved your talk. It was amazing. I'm really into performance talks, and I loved it a lot. It was pretty rough sometimes to understand it, but it really was cool to listen to you and see what performance gains you get out of your code. I loved it. It was really cool. Thank you very much.
You're welcome. Yeah. I'm currently setting up this GitHub sponsorship. So if you want to convince your boss to sponsor the Rust thread pool, for instance, you can do so in January.
Okay, yeah, sounds cool. Yeah. Do you mind to stay in Discord for a couple of minutes if someone has still some questions or something?
Yeah, absolutely. I will stay around. I see someone is typing already.
Yeah. Let's see. He thanks you. All right. Yeah. Thank you very much. Have a nice evening.
Pleasure. You too. Where can I stop the sharing?
Yes. I take this. I have one slide left. All right. Oh, this was so fun. Yeah, thank you very much, all your speakers. This was a lovely talk tonight. And I want also to say thank you to our sponsor, Microsoft. If you're interested in cloud computing or cloud programming, take a closer look in Microsoft Discover. There are some cloud transformation workshops which might be interesting for you. So take a look and have fun. Thank you very much and good evening. See ya.